All right, so here are the notes for 7.2. So now we have these rational expressions that we just talked about in 7.1. We reduced them or simplified them. We also found their domains. Now we're going to take them and we're going to multiply them and divide them. So because we're talking about fractions, you'll probably remember that multiplying and dividing fractions is very simple. It's when you get into adding and subtracting where you need a common denominator where it gets a little trickier. So we're just going to start right now, though, with multiplying and dividing. And as I kind of just intimated, you don't need a common denominator. Now, every time, I don't know if in your notes when you printed them, you had these little box. My printer didn't recognize the symbol, but it's just multiplication, so you can replace the boxes with little dots for multiplication. I used an old printer, which is part of my problem. The division symbols came out fine. Okay, so you'll remember when you multiply fractions, you look to cancel any top with any bottom, and once everything is canceled, then you're just going to multiply straight across. So if we look here, there's absolutely nothing I can cancel. So I'm going to just multiply straight across to get 16y over 3x squared, and I'm done. If we look at B, there's some canceling I can do. So for example, do you see where I can cancel this 5 and this 15? So negative 5 divides by 5, negative 1, and 15 divides by 5 3 times. That's all number-wise I see we can cancel. I also, though, see where we have an a cubed on the top and an a on the bottom. So we know how to divide those out and cancel. So this a is going to be gone. And if I take an a out of a cubed, I'm going to be left with a squared. And that's going to be on the top. Now I notice that I have a b squared on the top and a b cubed on the bottom. So this whole b squared is going to be gone, leaving me with simply a b in the denominator. So now when all is said and done, if I look on the top, I still have a negative 1 times 2, so that's going to be negative 2a squared left on the top. And on the bottom, I still have this 3 times this 3 is 9 times b. Now you might be asking, why isn't she reducing those fractions? If you have canceled everything that can be canceled inside the problem, you should never have to reduce at the end. Okay, so if we look at C, you can see that these in A and B, these were all little monomials, so we could just go ahead and cancel. But here, notice we've got some factoring that is going to be involved here. Before you do any canceling, you must factor what you can. So for example, if I go ahead and if I factor this top of the first fraction, I can factor out a 6, which will leave me with x plus 1. And that's going to be over 7 times, certainly the 14 is not going to factor, but how about this x squared minus 1? All of this factoring should be very easy for you now. This is a difference of two squares, and it factors into x plus 1 times x minus 1. So now we go ahead and we can cancel any factors that are the same on the top and on the bottom. So this 7 will cancel into the 14. 7 divided by 7 is 1. 14 divided by 7 is 2. I can cancel the x plus 1s from the numerator and the denominator. Is there anything else? I can't cancel this 2 and this 6 because they're both in the numerator. So if I look to see what's left for my answer, on the top I do have 6 times 2, which is 12. Over 1 times x minus 1, which is simply x minus 1. And I'm done. Why don't you go ahead and try D on your own, pause the video, factor and cancel, and then come back and we'll see if we match. So if I go ahead and if I factor everything that I can, if I look at the numerator of the first fraction, I can see that I can factor out a 5. Which is going to leave me with q plus t. Did you recognize in the denominator that that is a difference of 2 squares? So remember the rule for factoring a difference of 2 squares. It's going to be the square root plus the square root. So that's going to be t plus 2q times t minus 2q. If I go to the top of this fraction now, I have a GCF of a 2. So I'm going to take out that 2, which is going to leave me with t minus 2q. And the bottom, t plus q, that doesn't factor any further, so it just stays the same. All right, factor and cancel. Now it's time to cancel anything that's the same. Well, this t minus 2q and this t minus 2q on the top and the bottom will cancel. How about this q plus t and this t plus q? Those are exactly the same because, again, with addition, it doesn't matter what order they're in. It's only if it was subtraction that you'd want to factor out the -1 to help you. So I think everything's canceled. So what do we have left on top? 5 times 2, which is 10, over, and then the only thing left on the bottom is t plus 2q. And we are done. So now look at E. E is division. Well, the only difference between multiplying fractions and dividing is, remember, in dividing, you flip any fraction that is after the division symbol. So if I go ahead and rewrite this, you don't flip the second fraction, or the first fraction. You flip the second fraction, so it becomes times x plus 2 over 5x cubed plus 2x squared. So now it's a multiplication problem, which we've been working with. How do you multiply? You factor and cancel. So let's see what we can do to factor here. Here I can take out a greatest common factor of 2, which would leave me with 5x plus 2. This is a lot of good practice for factoring. X squared minus 4 on the bottom, that's a difference of squares, so that's x plus 2 times x minus 2. The x plus 2 on the top of the second fraction doesn't factor any further, but how about 5x cubed plus 2x squared? That is a GCF, or a greatest common factor, of x squared is going to come out. And if I divide that back in, I'm going to end up with 5x plus 2. So let's see what we can cancel. Well, this 5x plus 2 will cancel with this 5x plus 2. This x plus 2 will cancel with this x plus 2. It looks like that's it. So what do I have left on the top? There's simply this 2 over, and on the bottom I have the x squared and the x minus 2 left. So there we go. All right, I'm going to do F with you, and then I'm going to have you guys try G on your own. So again, it's division, so let's first just rewrite it as a multiplication problem. So remember, the first fraction stays the same, and then we're going to multiply by the reciprocal of the second fraction. It looks like the factoring is going to be a little bit more difficult here. 3a plus 2, is there any way that I can factor that? No. So that's going to leave the same. Now the denominator, to me, looks like it's probably going to factor. It's a trinomial. There's no GCF, so we're going to backwards FOIL. So how am I going to break up the 10a squared? Well, it's probably going to be 5a and 2a. How can I break up the positive 1 at the end? Well, only one way. It's going to be 1 and 1. And then because the last sign is positive, that means both of the signs are the same. They're both going to be negative. And if you go ahead and FOIL out these two binomials, you will see that you'll end up with 10a squared minus 7a plus 1. What can I do to factor the top of the second fraction? Well, there's a GCF. I can take out a 2, which would leave me with 2a minus 1. Isn't that convenient looking when you look down here? This bottom trinomial, there's no GCF, but I'm going to backwards FOIL. So 3a squared, let's see, that can break up into 3a times a. Now I have a 10 over here. Well, that's either going to be 5 and 2 or 10 and 1. I'm going to try the 5 and the 2 first. I think I'm going to put it as 2 and then 5. Let's see how that works. So remember, I need to get a negative 13. So if I FOIL these out, I'm going to have 3a squared. Outside, I'm going to have 15a. Inside, I'm going to have 2a. Can I get a negative 13 out of a 15 and a 2? Absolutely. It's going to be negative 15. So the outside term has to be negative and the inside term has to be positive. And that's factored. So now it's all factored. So let's cancel out any common factors. Well, this 3a plus 2, top and bottom will cancel, as will the 2a's minus 1's. I don't see anything else. So left on the top, don't forget, looks like there's a 2. And on the bottom, we have 5a minus 1 times a minus 5. All right, why don't you guys go ahead and see if you can do G. There is a twist. So just take that warning. Go ahead and see if you can do it. All right, hopefully you paused. Now we're back, so we're going to go ahead and flip the second fraction. So I'm going to go ahead and do that. So it's going to be times x squared minus 7x plus 12 over 2x plus 10. So I just flipped the second fraction. Now it's a multiplication problem. So I can't do anything with the 3 minus x. X squared plus 6x plus 5. I'm going to backwards FOIL. This one's going to be a little bit easier because there's only a 1 in front of the x squared. So we'll have x and x. What multiplies together to get 5 and adds together to get 6. Well, that's going to be positive 5 and a positive 1. Times this x squared minus 7x plus 12. That's going to factor for us. X and x. What multiplies together to get 12 and adds together to get 7. How about negative 3 and negative 4? Okay, remember if the last sign's positive, both the signs are the same. They're whatever the first sign is. And then what can I do to factor this denominator here, 2x plus 10? I can take out a 2, which is going to leave me with x minus 5. Now, look at this. Do you see anything that cancels? No. That's the twist here. I don't see a darn thing that cancels. So in other words, it's simply going to be all of these factors. And there we go. Sometimes that happens.